So there are two practice problems for chapter 2, both of them centering around density. So let's go ahead and start with the first one. So the first one asks us what volume of ethanol will have the same mass as 56.85 milliliters of aluminum. Okay, so it's asking us, it gave us the density of the two in our problem, and it's asking us to relate mass and volume. So density is mass over volume, and in the problem it said that the mass of aluminum is equal to the mass of ethanol. So the masses of the two are the same. So I'm going to rearrange this expression for density and solve for M. So if I do that and I multiply volume over, I get that M equals D times V. So since I have mass of aluminum equals mass of ethanol, I'm going to substitute in the density of aluminum, volume of aluminum on this side, and I'm going to substitute in density of ethanol, volume of ethanol in on this side here. So when I do that, I get the density of aluminum times the volume of aluminum equals the density of ethanol times the volume of ethanol. Okay, so now I'm just going to substitute in all the things they gave us in the problem. So the density of aluminum is 2.70 grams per milliliter, and they told us that the volume was 56.85 milliliters, and that's going to equal the density of ethanol, which they told us was 0.789 grams per milliliter times the volume. So now all I have to do is solve for the volume of ethanol. So volume of ethanol will be equal to 2.70 grams per milliliter times 56.85 milliliters divided by 0.789 grams per milliliter. So my grams per milliliter cancel, and I'm going to be solving for my volume of ethanol in milliliters. Okay, so let's punch it in. So we have 2.70 times 56.85. And then we're going to take that and divide it by our 0.789. So we do that, we get 194.54, we'll call it 37 milliliters. Okay, so let's go back through and look at our significant figures here. So densities are measured values. It's a mass, which is something that's measured over a volume, which is also measured. So if we go through and look at our significant figures, we have 3 here, we have 4 here, we have 3 here. Since we're only multiplying and dividing, we're just going to use the multiplication and division rules. So we have 3, we have 4, and we have 3. So our least precise or least number of significant figures is 3. So we're going to round this to 3. So 1, 2, 3. So that 4, because of what we have here, so that 4 is going to turn into a 5. And we'll call this 195 milliliters is our volume. Okay, so there is problem number 1. Okay, so problem number 2 is also a density problem. So problem number 2, they want to know what mass of copper we would have from a cylinder that had a height of 4.55 inches and a diameter of 0.65 inches. So a cylinder has this shape here. And so we have diameter, that's sort of the length across the circle. That's the 0.65 inches, and the height would be this here, and that is 4.55 inches. So in the back cover of your book or in the chapter, there's a list of formulas for volumes for a cylinder. The volume of a cylinder is equal to pi r squared h. So we're going to use this formula here to calculate the volume. So they did give us the density of copper in this problem to be 8.96 grams per milliliter. So if we calculate the volume and we use the density, we can go from volume to grams. So hopefully after going through this chapter and doing some of the practice, you realize what density is. It does give us the mass of an object over its volume, but it's a way to allow us to go in between mass and volume of a particular substance. So if we have information to get the volume like we have here, we can take that and then find the mass using the density. So that's what density does. Anytime we have a mass given to us, but we need the volume, we're always going to use the density to do that. Okay, so let's start plugging in. So volume equals pi, which is the 3.1415 times our radius. So radius is half of a diameter. So we'll have our 0.65 over 2 inches, and that's squared, and then multiplied by 4.55 inches. Okay, so let's put this in our calculator. So we have pi times our 0.65 divided by 2, and we're going to square that, and then multiply our height of 4.55. So we get a volume of 1.5098 inches cubed. So when we square our inches here to get inches squared, and then multiply it by another inches to get inches cubed. Okay, so this is our volume. In order to find the mass with our given volume here, we're going to need to make this unit match the volume unit here. So we're going to need to convert inches cubed into milliliters. Okay, so the way we're going to do that is using the fact that 1 milliliter is equal to 1 centimeter cubed. So in the metric system, what's really nice about that, there is a way to go from a three-dimensional space like length, width, and height, or pi r squared h like we did here, into volume units of liters, and that is using this relationship here, 1 milliliter equals 1 centimeter cubed. So we're going to take our inches cubed, and we're going to turn that into centimeters cubed. Once we do that, we can turn it into milliliters, and then once we have milliliters, we can use our density to get milliliters to cancel and solve for our mass. Okay, so I'm not going to worry about my significant figures just yet. So I'll keep all of these for now. So looking up on a conversion chart or getting a list of conversions from your book or from in the modules, it's 2.54 centimeters equals 1 inch. Okay, so to convert to centimeters, we're going to put our 2.54 centimeters in the numerator and the 1 inch in the denominator. But we need these to be in 3 dimensions, so cubes. So we're going to then cube and cube. So we're going to take our units and cube them. So we're going to take our 2.54 and cube that. Okay, so 2.54 cubed, that is 16.3871. Okay, so we're going to take that and multiply it by our 1.5098 from above, and we get this here. So our volume in centimeters cubed is 24.7417 centimeters cubed. Again, I'm not worrying right yet about significant figures. I'll go back and look at that at the end when I'm ready to do my final rounding. Okay, so we do know that a centimeter cubed is equal to a milliliter. So this is also 24.7417 milliliters. Okay, so now that I have that, I can use my density of copper to solve for this. So I have 24.7417 milliliters times 8.96 grams per milliliter, where my milliliters cancels here, and I'll have my mass. So we have our volume that we just solved for, our 24.7, then we're going to multiply that by the density of copper, 8.96. So we do that, we get 221.685. Now our units are grams. Okay, so the problem is essentially done in terms of the math. Let's go back and look at these significant figures. So in our very first calculation we did here, let's track what we did. So we're just multiplying and dividing, which is nice. So we just have to use our multiplication and division rules. This value here has 2 significant figures. This one here has 3. So this is an exact number. Exactly 2 of a radius equals a diameter. So we don't have to account for this one here. So we have 2. So we should have 2 significant figures here if we were to round at that point. So going through here, we would have the 2 significant figures. This is an exact number, so we'll call this infinite. Here, I'll put this at the 2 also, so we remember that 2 is infinite. So we still just have our 2 significant figures here. So 2 significant figures. This one has, so we have 2 here. This one has 1, 2, 3. So our final answer would just have the 2. Okay, so if we wanted to round this, we're going to round to the tens place. So we look to the next digit. It's a 1, so this would be 220 grams. Where that 0, you could leave it because we wouldn't count that as being significant. But if we really wanted to show that it is not significant, we would call it 2.2 times 10 squared grams. So that's our mass of copper if we had a cylinder of copper with these dimensions here. Where again, because we had a volume and we were finding a mass, we used the density to do that. It relates the mass of an object to the space that it occupies.